Welcome back to Learning with Merit. Today we're going to take a look at some Python conditionals. In this file we are going to take a look at a review of Booleans and relational operators, logical operators. This is going to be Boolean expressions primarily. Then we're going to look at Boolean expressions. We're going to look at Python indentation and code blocks. We're going to look at if statements, if-else statements, chained conditionals, nested conditionals, ternary operators or shorthand conditionals, and finally in Python what we call match statements. First, we have a quick review of what Booleans are, what relational operators are, logical operators are. These are the things that we are going to use to create Boolean expressions later. So we use Booleans, relational operators, and logical operators in our conditionals quite often. We need to remember that Booleans are true or false values, and this is how we represent the literal true and the literal false in Python. Remember that our relational operators are mostly inequalities, like we remember from a math class, but they are used for relationships, and typically we are comparing two things. Relational operators are going to tend to resolve to a Boolean, right? So we say this as they evaluate to a Boolean, a true or a false value. And then we need to remember that our order of operations is left to right on those relational operators. So here are our symbols. We've got greater than, less than, greater than or equal to, less than or equal to, and not equal to. And here are our different symbols for those. As well as special to Python, we have these particular operators. Now, they're not special in that other languages don't have operators like this. It's just they don't always use these same operators in the same way. So we have is for identical to, is not identical to, in is for membership or a part of, and then not in is for also for membership, but in this case not a part of. Then our logical operators, we need to remember that we have not, and or. And the shorthands for this is not is opposite. So if it's not true, it's false. If it's not false, it's true. Then we have and. This is a both type operator. So true and true is true, and any other combination is false. Then we have or, at least one in order for it to be true. So the only time that we have false is false or false, and that gives us false. All of the other combinations are true. And we need to remember that we could draw out some truth tables if we needed to. I encourage you to go back and look at the operators if you are still confused on how not, and or work. All right, let's take a look at some Boolean expressions. So Boolean expressions are going to evaluate to a true or a false value. All right, they're always going to be true or false. That's how they evaluate. So we use these with conditionals and loops in order to control what's going on or to make some sort of decision based on whether or not we get true or false back. So remember, we have our operators here, and then we have a couple of different examples. So here we have a string comparison, for example. So here I'm saying text is equal to text. In this case, what that means is, are these two things equivalent? Well, since they are the same value, we get true out, and that's what it would print. All right, and if I were to hit Control J, actually I need to save first. If I hit Control J and I do Python tutorial.py, you see I get true out. Then if we do a number comparison here, so here we have something with an inequality. So I'm doing 5 is greater than or equal to 2. Well, we know that's also true, so now it should print out true if we save this and run it. So we do the same thing. Run it again, and we see we get true and true again. Now if we do some variable comparisons, remember we could do all of this, any of this stuff, with variables as well. So here we have x is equal to some text and y is equal to other text. This could be numbers, this could be floats, this could be literally anything, any data type that we're working with. We could set equal to a variable like x or y and use that. In this case, we're checking if x is the same as y. Do they store the same value? Well, the problem is some text and other text are not the same value. So this prints out false. So if I save that, we go back over here, we run it one more time, we should get true, false, and we do. So the first two were true, and the last one was false. Let's take a quick look at some Boolean expression examples. So here I have defined two variables. I have A and B. A is equal to some user input, and this is going to be cast to an integer. So it's going to tell me to type in an integer value. Input is going to return a string, and then int will convert that string into a number. And then B is going to do basically the same thing. It's just going to take in a second integer. So let's take a look at some Boolean expressions we can work with these numbers. So if I did, for example, A greater than B, and I go over here and we run our Python tutorial program, it wants me to type in an integer. Let's do 5, that's going to be A, and then 2, that's going to be B. So I get true out. 5 is, in fact, greater than 2. If I run it again and I reverse the numbers, I could do 2 and then I could do 5, and you'll see that I get false. So it takes in those numbers. In the first case, it was 5 and that was 2, and in the second case, that was 2 and that was 5. You notice how each time we got a Boolean out. So now what we're going to do is we're going to add, we're going to add to this. So now we have A is less than B, so we should get, these two should be the opposite no matter what we end up doing. So if we go back over here and we run clear, and then we run the commands again. So type in integer, I'll do 5 and I'll do 2 again, and you'll see is A greater than B, is 5 greater than 2, true, is 5 less than 2, false. Right? And then if we do the same thing again and we change the values, so 2 and 5, we get false and true, and you see that they're flipped just like that. So remember, these are just evaluating two Boolean values. Let's add a few more and start taking a look at what they do. So this is greater than or equal to B, this is less than or equal to B, this is not equal to B, and this is equal to B. So let's save that and see what we can get. So if I do Python tutorial.py and I do 5 and 5, well, what we get is false, false, true, true, false, true. And if I take that and we actually look at it compared to what we've got, well, the first one is A greater than B. Well, is 5 greater than 5? It's not, so false. Is 5 less than 5? It's not, so false. Is 5 greater than or equal to 5? True. Is 5 less than or equal to 5? True. Is 5 not equal to 5? False. And then is 5 equal, meaning is it equal to 5? True. So you notice all of these are returning a true or a false value. We can use that for a lot of different things. Here's another example. So this time I have 3 variables, A, B, and C, and I'm going to take in 3 values. Actually, that should say integer. So it's going to take in 3 integer values, and again, remember that that input is going to return a string whether or not I type a number, and then the int there is designed to convert that string into a number so that we can do this stuff down here. This first one is going to use a logical operator not, so this is going to do the opposite of whatever this says. So if A is equal to B, not will turn that to false. If A is not equal to B, not will turn that to true. So it will print out true if A is not equal to B, and it will print out false if A is equal to B. And then here we have A greater than B and A greater than C. So the only time this will be true, this whole thing will be true, is if this is true and this is true. If they're both true, the whole thing will print true. And then this one right here, A greater than B or A greater than C, this will print true if at least one of them is true. So if A greater than B or A greater than C is true, the whole thing will print out true. So let's take a look at that in our code here. So it wants me to type an integer. So let's start with A and B being equals. We'll do 5, 5, and 2. So here's what we got. So 5 and 5, A is 5, B is 5. So that's true, that's 5 equals 5, which is that's true. So A equals B, that's true, and then not turns the true to false. So it prints false. Then this one right here, A greater than B. Well, 5 is not greater than 5, so that's false. I don't even have to check the second one because they both have to be true. So the whole thing is false. Then the third one, A greater than B, well, that's false, but is A greater than C? I need to check that because it's an OR. Well, 5 is greater than 2, therefore the whole thing is true because at least one of them was true. Let's try another one here. We'll change the values this time. This time, I don't know, let's do like 4 and 6 and 7. We'll do that. So A is 4, B is 6, and C is 7. Let's see what we get. So is A equal to B? Well, that's false. Not false is true, so we get true out. And then the second one is A greater than B. Well, A is not greater than B, and it's not greater than C, so we get false on this one because I don't even have to check the second one. This one, A is less than both B and C, so because both of these are false, the whole thing right there is false, so we get false out on that. We'll do it one more time. Let's do Python tutorial.py. There we go. All right, let's do one where A's fairly large. So we got 10, 5, and 4. So A is 10, B is 5, and C is 4. So we get true on all of them. Well, is A equal to B? 10 and 5 are not equal, so not false is true. Then this one, is A greater than B? Well, 10 is greater than 5, so true. Is A greater than C? 10 is greater than 4, so true. True and a true is true. And then is A greater than B? Well, that's true, and A greater than C is also true. So because both of them are true, at least one of them is true, the whole OR here is true. So that's why we got true on all of those. Let's talk about indentation in Python. It's extremely important that we understand that indentation creates the blocks of code. So these are groups of statements that are executed together as a unit. So that's a block of code, right? Each indentation level represents a higher level of code structure. This is typically going to be used in conditionals, loops, functions, and classes. Since we're finally talking about conditionals now, we need to understand the importance of our indentation. All statements within the same block must have the same level of indentation. If you have it off by even a space, it will break, it will be wrong, the computer will throw a fit. It has to be perfect. So the end of a block is indicated by the decrease in an indentation level. Let's take a look at this. So here we have conditions. Conditions are going to be a true or false. They're going to evaluate to a true or false value. So here we have a basic conditional with an if statement. So if condition, you notice how I have indented here. Now, one of the things that you'll notice is this is 4 spaces, right? 4 spaces. So we have indented 4 spaces to be inside the condition, and then when I unindent, I'm no longer inside of that if statement. I'm no longer inside of that block. Let's look at another example. So here's a while loop. So you see I've done basically the same thing. I've got that 4 space indent, and when I'm exiting, I unindent. Look at a for loop. Same thing. I got that 4 space indent, and when I'm exiting, I unindent. Function definition. This is a function definition right here. Again, you'll see the same indentation. So every time I'm creating a code block of something, I'm using that indentation level. So if we have nested indentation, so blocks inside of blocks, this is what it might look like. So here I have the start of the function code block. And then inside of that, I have created a for loop, and you'll notice I've indented once again for the for loop. And then maybe I create a while inside of that. You'll notice once again, I've also indented one more time. And maybe I have an if inside of that. You'll notice I've indented again. So if you look at this, you can see these different little characters I've used to sort of encompass everything. So if we look right there, there is the if block. And then surrounding the if is the while. Surrounding the while is the for, and surrounding the for is the def. So every level I have to indent as I go inside of each of these different little control structures. Now, one more thing that is important for us to remember, indentation is typically achieved using spaces or tabs. We do not want to mix spaces and tabs. Remember, tabs are a special character. So we need to be very careful about how we do this. It can lead to syntax errors and inconsistent behavior. Python 3 actually disallows mixing tabs and spaces for indentation in the same source file. The good news is if you're using an editor like VS Code and you hit the tab key, it typically is an issue because it automatically converts that to a space, right? All right, let's talk about if statements. So these are our simplest forms of conditionals. If statements are all about allowing us to make a decision with the computer, right? If this thing is true, then I want to do this. If it's not, I want to do something else. Right? It allows us to tell the computer, or basically teach the computer, how to make a decision based on something we would make a decision on. So let's take a look at this. So our condition, there's always going to be some condition in an if statement. That's going to be a true or a false value, some evaluation to a true or a false value. That means it could be a Boolean expression, and it will typically be a Boolean expression. So now the condition in parentheses is a Boolean expression. So if we look at this, we say if, then inside parentheses after the if, we are going to provide the condition. This is going to be some Boolean expression. Now, sometimes we can get away with it just being true or just being false, but that's what Boolean expressions evaluate to anyway. So the condition is always some true or false value. Regardless of how complex it gets, it's always going to result in a true or a false, right? Then we need to end in a colon. Now, what this says is we're about to go to a new line. After that little colon, we're going to indent. This is extremely important. We are indenting 4 spaces to be inside of the if code block. If you do not indent, you're going to run into an error. So I've indented to indicate I am inside of this if block of code. And this is whatever code we write here is what we want to happen if the condition is true. So this code block here is going to happen if the condition is true, right? Then we unindent 4 spaces to be outside of the if code block. This is an extremely simple way of looking at it. So if condition is true, we run this code block. If it's false, we literally just skip it. That's all we do. Simplest form of a conditional there could be. If condition is true, we run the code block. If it's not, we move on. So here are some other little examples here to help you sort of visualize what we've got. We got a whole block of code here. Inside of this code block, we have the code that will run if the condition is true. So it runs this block when condition is true, skips it if condition is false. Right? Each new if is going to start its own separate conditional. So if I have if true, run this block, and then I have if the condition is false, we're going to skip this block, right? These 2 if statements are completely independent of one another. They don't have anything to do with each other. So it's possible if both of them were true, both of their blocks would run. It's possible if both of them were false, both of their blocks would be skipped. It's possible if one's true and one's false, one is skipped and one is ran. Right? They are totally independent of each other and have nothing to do with one another when they are written like this. So 2 separate ifs are totally independent. All right, some special notes that we need to know about dealing with conditionals now that we've talked about if statements. It's important that we understand that there are ways in which Python is going to evaluate certain data types as a true or a false value. And this is going to lead to some errors in your code if you're not careful. So let's look at what these things do. If you write an if statement, you will get some output. That output may even be correct. You may even think that's working correctly, but it won't work for every case, right? And this is because sometimes Python is going to do things that counts what you have written as a true or a false value, and it just so happens to work out sometimes. So let's look at this. Integers and floats. Anything that's a non-zero number, that means including negative numbers, anything that's not 0 is evaluated as true. So if I did if 1, 1 is true. If 2, 2 is true. If 3, 3 is true, so on and so forth. If I did negative 1, negative 2, negative 3, those would all be evaluated as true. If I did if 0, that would be false. Same thing with floats. Any non-zero numbers. Now, strings, lists, tuples, sets, dictionaries, any of these that are not empty are evaluated as true. So if I have a string with anything but nothing in it, that's true. A non-empty list is true. A non-empty tuple is true. A non-empty set is true. A non-empty dictionary is true. Now, what I will tell you is I have found in the past that a lot of people will accidentally create a tuple, don't know that they're creating a tuple, but will accidentally create a tuple when they're writing a conditional, and then it just so happens to work the first time, and they think they've done it correctly, and they haven't. They've made a mistake. It's important that you understand that if it's not empty, and you've made a tuple or a list or a set or a dictionary or a string, it evaluates as a true value. So we need to be very careful. Any function, method, lambda, or class, any of those are always evaluated true. So if you pass a function into an if statement, or a method, or a lambda, or a class, it will be evaluated as true every time. The only kind of weird one is an object. Now, objects by default are evaluated true, but you can actually change this. So some objects will not always follow the any object is true. But if you don't know, just assume that the object is evaluated as true. And if you get some weird behavior, then you need to go and look up if that has been changed for that particular object that you're using. Okay, these are extremely important to know when we're writing conditionals because we make mistakes, and we make a mistake that evaluates to a number, and any number that's not 0 is evaluated as true. Okay, I see this a lot with beginners. We'll do some math and it will return a number, and we think that we've done some sort of check, and we haven't. All we've done is returned a number, right? And that number, if it's not 0, is true, and your conditional will run and the computer will not complain. But it won't always work the way you intend it to work. And so we need to be very careful about checking these special notes. All right, let's take a look at some if-else statements now. This is a little more complex if case. So what we do in an if-else statement is we're going to say if the thing is true, if the condition is true, run the if. If it's not, run the else, right? So we're going to run something. It's either the if block or the else block. So let's take a look at that. So here we have an if else. So here we have if and then a condition. If the condition is true, we run the if block and we skip the else. If the condition is false, we skip the if block and we run the else. Now, the thing about the else is this is technically when all the conditions above it are false. And we'll see a case later where we've added some additional conditions up here where the else block will only run if all of the things above it are false. So remember one time, if the condition is true here, we run the if. If the condition is false, we run the else. It's as simple as that. So, a couple of other examples down here. So if true, we run the block and we skip the else. If it's false, we skip the block and we run the else. It's as simple as that when you work with these. We will take a look at a few examples here in a minute to make this maybe a little more concrete. All right, let's look at some chained conditionals. So we call this an if, elif, else. Now we can have as many elifs as we want. Basically, elif is a shorthand for else if. That's what that means. So if we want to have multiple conditions, right? We want to have multiple checks in here. That's when we throw in the elif. So we say if, and then we have some condition, right? And if that condition is true, we run the if block and we skip everything else, right? If the if condition is false, then we check the elif condition. If the elif condition is now true, we run it and we skip the else. If both the if and the elif condition is false, then we run the else block. Let's take a look at those examples. So here we have if true, elif true, and else. Well, the if is true, so we run the block and we skip everything else. Even though the elif is true, we're still skipping that block because the if was true. This is important to remember because these are not independent of one another. They are connected. So if the if is true, we run the if, and we skip the elif, and we skip the else. Oops. If the if is false, So if false, we're going to skip the if block. Elif is true, so we run that block and we skip the else. And then last little example, if both of them are false, so if is false, the elif is false, we're going to skip both those blocks and we run the else. You'll notice how the else doesn't have a condition. That's because the else's condition is that everything above it is false. So in this case, elif and if are both false, so the else runs. These are called chained conditionals because you can have as many elifs as you want. So we could do if, elif, 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 else, right? Most of the time, if you find yourself doing that, there are some different workarounds and things that you can do, but you could potentially have a whole bunch of elifs in there if you wanted to. Remember, each of these ifs, when I start a new if, I start a new chunk. So this if right here is independent of this one, is independent of this one. Okay, so each of these ifs will run separately. Let's take a look at some nested conditionals. So this is where we put one conditional inside of another. So a quick example, we could have if true and then an if inside of that, and this block only runs if both are true. So here's what happens. This if checks if this condition is true. If it is, then we run this block that's inside of it. Well, now we have a conditional inside. This conditional is going to check if some other condition is true. If that's true, then this block finally runs. So both things have to be true. Both ifs have to be true for this thing to actually run. Now let's look at a little more concrete example. Here we have three variables, A, B, and C, and they could be the values true or false, each of them. So let's make a large nested conditional. So there are many different combinations we could have. So here we have an if else. So if A, meaning if A is true, print A is true. Otherwise, we're going to print A is false. Well, maybe I want to check if more than just A is true. Maybe I want to check if A and B and C is true. So we're going to go and we're going to add to this. So we're going to say, all right, if A is true, then we're going to print A is true. But then you see how we've indented here. We're going to check if B, right? So here's what will happen. If A is true, then we continue on. If A is false, we just skip all the way down here to the else and print A is false. That's as simple as that. But if A is true, we print A is true, and now we're going to check if B is true. If B is true, we print that A and B are true. If B is false, then we print A is true, and then print A is true again. That's it. That's what the else is for. Now, let's say maybe we want to check C as well. So we add yet another one in there. You notice how we continue to indent. So what we've done here is now we're going to check if A is true, then we print A is true. If B is true, then we print A and B are true. If C is true, then we print again, we say A, B, and C are true. Okay? But remember, if A is not true, meaning false, we skip down here to this else, and we print just A is false. If we found A was true, but B is false, then we would print A is true, and then we would come down here and just print A is true again, because that's the else for this if. Then the last one, let's say that A is true and B is true, then we would print A, comma, B are true. Then we would check this if right here and say, is C true? If C is true, then we print A, B, and C are true. But if C is false, then we would print C is false. So in the event that A is true and B is true, but C is false, we would print A is true, A and B are true, C is false. And that's how this large nested conditional would work. Let's take a look at some examples of some conditionals, because I think this will make this a little more concrete. So here we have, I want to write a conditional to determine if a number is even or odd. So here I have num, and num is just going to be whatever input I type in as a number, and this is going to be an integer that we type in. What I can do is I can use an if, and then I can use this right here. This is my condition. And the condition is actually checking if these two things are equal. It's checking if num modulo 2 is equal to 0. Now what num modulo 2 does is it says, is num divisible by 2? And what that really means is it's going to return the remainder. So if num is 10, then the remainder of 10 divided by 2 is 0. So that means it's divisible by 2. But I could also check 9, for example. So 9 divided by 2 would give me a remainder of 1. And since that's not equal to 0, then we might do something else, right? That'll tell us if the number is even or odd. If it's odd, we get a remainder of 1. If it's even, we get a remainder of 0. So if this is true, meaning that the remainder is 0, we print even. If it's not, else, we print odd. So if it's not 0, then we print odd. So this is a great example of something we might do with the conditionals. We check in, okay, is the number even? If it is, we're going to do something if it's even. Otherwise, we're going to do something if it's odd. Let's take a look at this with our fancy tool here. So we're going to do a Python tutorial like this. It's going to ask for some input. Let's put the number 3, and you'll see that it says odd. We'll run it again. And let's do the number 4, and you'll see that it says even. And this should work for any number that I give it. So let's go crazy. Let's do a really wild number. Okay, we're gonna do something really big here. So we'll type in a large number, and you see that it's odd because it's divisible by 2. Or sorry, you see that it's odd because it's not divisible by 2. Right? We get a remainder of 1 there because it ends in a 9. All right, here we've got another great example. So we're going to determine if a number is a positive, negative, or a 0, right? And again, we're going to take an input, and we're going to figure out what that is. So here I have an if, elif, else, so a chain conditional. And my first check is going to be, is num greater than 0? If it is, I want to print positive, because that's how I know a number is positive. It's greater than 0. And then I need to check, is the number less than 0? So if it's not greater than 0, then I need to check if it's less than 0. If it's less than 0, we print negative. If it's not less than 0, then there's only one number it could be. If it's not greater and it's not lesser, it could only be 0. So we just print out 0 like that. Okay. So let's actually go through this and see how that works. So let's give it a clearly positive number, positive 1. It says positive. So what it does is it says, is 1 greater than 0? Since it is, it prints positive. Let's do another one. Let's give it a clearly negative number. So we'll do negative 1, and we get negative. Now the way this works, it says, is negative 1 greater than 0? It's not, so it skips this code. It goes here and checks, is negative 1 less than 0? It is, so it prints out negative and skips this. And then the last one, we'll check that last case. We'll do 0. And it prints out 0. So what it does is it says, is 0 greater than 0? Nope, so it skips that. Is 0 less than 0? Nope, so it skips that. Is the only thing it could be is 0. So there's not even a check there. It's just else. Both of these were false, so it prints 0. The only thing it could be is 0 if it's not greater or less than 0. Here's another good example. So we're going to write a program to check if a number is between 0 and 10, or between 10 and 20, or between 20 and 30. So you see it gets a little more complicated now. Now I have to incorporate not just relational operators, but also my AND operator here, my logical operator. So we're going to take in some number, and we're going to check if that number is between 0 and 10, or 10 and 20, or 20 and 30. So let's look at this. So we're going to say, all right, if 0 is less than or equal to number, and number is less than or equal to 10. That's checking if number is between 0 and 10, including 0 and 10. If this whole thing is true, so meaning number is greater than or equal to 0, and it's also less than or equal to 10, meaning true and true, then we will print out number is between 0 and 10. If the whole first thing is false, we skip that code. We come down here and we check, all right, is it greater than 10, and is it less than or equal to 20? If those two things are both true, then we say, well, hey, it must be between 10 and 20. Then we check again, say if we have two elifs here. We check if it is greater than 20 and less than or equal to 30. If that's true, then we know it's between 20 and 30. Otherwise, it must not be in any of the ranges. So we're just going to say is not in range. So let's try this code. Run right there, and let's say, all right, let's pick an edge case. Let's do 40. It says 40 is not in range. Okay, let's do something that's clearly between 0 and 10 next. So we're going to do, I don't know, 5 is clearly between. So it says 5 is between 0 and 10. That makes sense. And then we've got, let's do something clearly between 10 and 20. So we'll do 15. And it says 15 is between 10 and 20. And see what it did right there is it said, all right, is 15 greater than or equal to 0? That's true. But 15 is not less than or equal to 10. So we got true and false. So skips this block. Then we look at this one. We do, well, 15 is greater than 10 and it's less than or equal to 20. So we print this. Okay, let's do another one. Let's do one that's clearly between 20 and 30. We'll do 25. And we see that we get 25 is between 20 and 30. Makes perfect sense. Again, same thing. What it does is it checks if it's greater than or equal to 0, which that is true, but this one is false, so it skips that block. This one is true, but that one is false, so it skips that block. And then in this case, that one is true and that one is true, since we're using number equals 25, and so it runs this block right here. And then, of course, in the first case, when we did 40, 40 is not in range because all of this is false. The if, elif, and if, elif, and elif all evaluate to false because 40 is not less than any of these values, less than or equal to any of those values, and so it prints out numbers not in range. All right, one more here. So we want to check if a character is a vowel or a consonant. Right? What we have here is char is our variable, and we're going to take in some input, and we're going to turn that input into a lowercase. So if someone types in an uppercase letter, it goes down to lowercase so that you don't have to worry about case problems when dealing with the pieces here. So here's what I've done. I've used the in operator, which is it checks membership, which means it's going to check if whatever character we provide is inside this string. If it's one of these characters inside of the string, then it's true. If it's not, it's false. So let's take a look at this. So if I did like A, for example, well, is A in this string? It is. That's true. Therefore, we get A is a vowel. Let's actually try that. So I'm going to type A. It says A is a vowel. Then what if I did a consonant, something like M? Well, M is not in this list. So M is a consonant. It will run the else block because the if block is false. So it'll skip this and it will run that. So let's try that. This time I'll type M. That says M is a consonant. So it's that simple. Now we'll talk about ternary operators real quickly. So these are shorthand conditionals, and they can be super confusing in the way that they are written if you are not careful. And my suggestion is you only use ternary operators, one, if you fully understand how to write them, and you are only using them for simple conditionals. If you start trying to use ternary operators for complex conditionals where you have like multiple elifs in there, they're going to get so confusing that even people who know what they're doing can't read them. Okay, so ternary operators are shorthand. They are meant for simple if statements, simple conditionals that you want to shorten how much you're writing for them, not for complex conditionals to make you look like a genius programmer when nobody can read your code. So let's take a look at some examples of this. The syntax for a ternary operator. And first of all, why do we even call it a ternary operator, right? So ternary refers to the fact that it always takes 3 operands. So the condition that is going to be evaluated, the expression that's returned if the condition is true, and the expression that is returned if the condition is false. So let's take a look at how this works. So the syntax is we're going to do X if this condition is true. Else, we're going to do Y, right? So what this means is do X if the condition is true, otherwise do Y. It's as simple as that. Now, I say simple. It's confusing if you don't really know what you're doing. So let's take a look at this. Here I have 3 variables. We're going to print if. That's what we're going to do. That's our X here. If, what's our condition? If true. So if this condition is true, which true is true, then we would print if. Otherwise, we would print else. Basically, this is designed to show you which thing is being ran. Well, since the condition is true, that means we would print if. If this was false, we would print else. Here's another example, a little more complicated this time. We've got print if x is greater than 0. It is, we would print if. But now our else is going to get a little more complicated. Else, I did print else if, but then I put if. So now what's happening is if we were to run the else, we're not in this case because x is in fact greater than 0. But if we did get to the else block, that's when we would run all of this next piece. So I'm going to go ahead and finish it out. So this is the else part. This is what we evaluate if the else is true. This is actually how you do an else if you're using a ternary operator. You see how confusing this is? It can be very confusing. So I recommend you don't do this if you're going to have to do an else if. Right? It should be very simple, quick if else's, that type of stuff, and only if you are ready and truly understand how if conditional statements work. Let's talk about match statements. So match statements are used for whenever you typically have a simple expression and you have a lot of things to match it to check it against, right? And so instead of writing, 1,000 elif statements, it's oftentimes a little easier to write something like a match statement. And in other languages like Java, for example, they call them switch statements. So you may find that there are different names for these different types of statements. So let's take a look at a match statement. We're only going to run whatever the first matched pattern is, and then we're going to be done, right? So it's going to find whatever the first thing is, run it, skip everything else, right? It's going to compare some expression to one or more what we call case blocks. So let's look at how this actually works. Let's say I get an HTTPS response code, right? So this is like our 400s, 500s, 200 codes that we see. We're going to say, all right, match HTTP response. By the way, this is just a placeholder. So it could be any number, And then it says match HTTPS response. So maybe we match a 400. So we're going to see, is HTTP response a 400? If it is, we print bad request. If it's not 400, we check the next one. And the next one, and the next one. And we keep going until we find one that it actually hits. Now, if we need a base case, we need some case that's going to run if nothing else gets hit. That's what we use this little underscore for. So the underscore acts as a wild card and always matches. So if we make it through 400, 401, 403, 404, 418, and 500, then we would finally go ahead and say an error occurred, right? This is only going to run if one of these things above it does not get matched. If 400 gets matched, nothing else gets ran. Okay, we stop whenever we get to the point where we have matched something. If there are no matches, the program just continues, much like an if statement. So if we have a basic if statement and it's false, it just skips it, moves on to the next part of the program. Let's look at some other examples here. So we can combine literals if we want to into one case. So we could say 400, 401, 403, 404, 418. If any of these occur, just print it's a client-side error. If we get 500 or 501, print it's a server-side error. Same thing, we're using a comma to combine those literals into one case. We could also do something called adding a guard. This is where we throw in an if statement, or a shorthand little if statement inside of our match to guard against certain things. So here we have A is equal to false, character is equal to 97. So if we create a match statement here, so we say match character. So if 97, so if character is 97, if A. Well, if A is not true, then it doesn't do this. It will not print A, right? In this case, it won't match 98, won't match 99. It'll print nothing, okay? So this line is only going to execute, this one right here is only going to execute if the guard is true and the case matches. So you can do simple little if statements like this to check and guard certain things, because you never know. There are a lot of different use cases for this. You might need to check something as well as match a case, and you can do that right inside.